In the last 150 years, scientists and inventors have built on the understanding of the differing wavelengths and frequencies of the electromagnetic spectrum to develop a dizzying array of technologies that have benefited all of us. Radio waves have the lowest frequency in the electromagnetic spectrum. When a radio program is broadcast, an antenna sends out radio waves at a certain frequency, or number of waves per second. Every radio station has its own frequency. When we tune in a station, what we are doing is adjusting our radio to the same frequency of the radio wave broadcast from the station's antenna. When they are both on the same frequency, our radio receives the signal from the station and transforms it into sound waves, which we can hear. Many radio waves can be broadcast at the same time. As long as they are transmitted on different frequencies, none of them will interfere with the others. Television works in much the same way, but the frequencies are higher in the electromagnetic spectrum. An electric signal carrying information about the image arrives at the back of the television tube. Those signals send electrons to the front of the tube, creating dots of light on the screen. Those dots are quickly assembled as an image, which changes so quickly it appears to move and provide action. The curvature of the Earth limits the reception range of telecommunication signals, since electromagnetic waves usually travel in a straight line. In recent years, satellites have been placed in orbit high above Earth to get around this problem. Signals are sent from Earth to the satellite and back to Earth again. In this way, signals can be sent all over the globe. Increasingly, electromagnetic waves with higher frequencies are being used. The signals in cellular phones and telecommunication transmitters are microwaves. The same type of wave is used in microwave ovens. Radar is another use. It was developed in the Second World War to detect incoming enemy airplanes. Microwaves are sent out from a tower. The beams bounce off incoming aircraft, and some of the signal returns to the tower. Instruments read this signal to give the location of the aircraft, its speed, and direction. Today, radar is an essential tool for defense and civil aviation. Infrared rays have been adapted to help people see in the dark. Ultraviolet is used in fluorescent lighting. X-rays are used for dental and medical applications because their short wavelengths can penetrate soft tissue and show bones. The difficulty in using the waves that are higher in the spectrum is that they can be dangerous to humans. Overexposure to X-rays, for example, can lead to serious medical problems. But the more that is learned about electromagnetism, the more applications are found.